Good morning, class. Welcome to the fourth video lecture of ME269, Material Science and Engineering. So in this video, I will be discussing the material testing, and we will focus on the destructive test of the material. Pag sinabi nating destructive testing, sinisira natin yung specimen natin para malaman natin or mapag-aralan natin yung mechanical properties niya. So let's get started. So in testing of materials, marami ang klase. First, we have tensile testing, shear test, bending test, torsion test, toughness test, and hardness test. Kung mapapansin nyo, walang compression test kasi ang assumption, if the material is ductile, the tensile property of the material is equivalent to the compressive property of the material. So first, let's talk about tensile testing. So in tensile testing, it determines the resistance of materials under tensile force. So the test is accomplished by first subjecting the specimen to a controlled tension until failure. So hinihila siya, no? Magkakaroon tayo ng tensile force until na magkaroon ng fracture with our specimen. Next, measuring and recording the required parameters. So usually naman ang mga required parameters dito will be the force applied to the specimen and then the elongation that happened to the specimen para mahanap natin yung stress and strain natin. So lastly, using those measured parameters, pwede na natin ma-obtain yung stress strain curve natin and pwede na rin natin ma-evaluate yung property niya. Just like we have discussed from the last topic, so we can determine the other mechanical properties of the material natin using this stress strain curve natin. So pwede nating mahanap yung kanyang strength, ductility, and then yung toughness niya. Next, let's talk about tensile specimen. Yung specimen yung object na ginagamit natin para pag-aralan using a machine, specifically with tensile testing application. So basically, it has two parts, which are shoulders and gauge. So ito ang itsura niyan. So ang shoulders natin, yun yung dalawang dulo or dalawang ends ng ating material. Kung mapapansin nyo, it has a broader cross-sectional area and then the gauge has a smaller cross-sectional area. The purpose of the gauge kung bakit siya merong mas maliit na cross-sectional area kasi dito natin siya ini-expect mag-fail. And then mas malaki to, yung shoulders natin kasi dyan usually kinakapit yung machine natin. Okay? Kung mapapansin natin, ang ating mga specimen is merong different shapes, no? Kahit gaano kalaking or gaano kaliit na shape yan, the mechanical property of that specimen is the same. Kasi lahat naman ng mechanical property ng, kung pare-parehas lang naman sila ng object or alloy, pare-parehas din ang mechanical property niya. Kaya walang pake yung mga nagtetest dun sa size ng specimen as long as kasya siya dun sa machine na ginagamit natin for testing. So pag-aralan natin yung mga different types of shoulders na ginagamit natin. So you can see we have 5 types of shoulders na ginagamit. We have threaded grips. So yung threaded grips, kapag threaded din yung ating part dun sa machine na nag-hold sa kanya. We have serrated wedge. The serrated wedge, yun yung parang pangkalang, no? Para pag hinila mo siya, hindi siya matatanggal. We have also split collar. Just like this, pangkalang din. And then serrated wedges for flats. Kasi itong A, B, and C, these are for cylindrical specimens. And for flat specimens naman yung D and E. So si D and E, mas malaki lang siya, may pangkalang din. And then parang ginigrip lang siya using clamps. And lastly, the pin type. So may butas doon sa ating shoulders para dyan pinapasukan ng pin. The disadvantage of the pin type is that meron kang shear force between those pins. No? As long as dapat mas mataas yung shear strength ng pin kaysa dun sa tensile force. Kasi baka mangyari, mas madaling masira si pin, no? Kaysa dun sa mismong material natin. Next, pag-usapan natin yung equipment na ginagamit for tensile testing. So, basically, the machine that is used in tensile testing is called Universal Testing Machine or tinatawag natin minsang UTM. So, we have two basically we have two basic types of UTMs. We have hydraulic powered and electromagnetically powered. Sa hydraulic powered, karaniwang ginagamit sa mga small setup. So we have this hand wheel. This hand wheel has a power screw. No? So yung power screw, tinutulak niya yung hydraulic fluid with the cylinder. So yung cylinder na yon, since minumove niya yung hydraulic, siya yung nagko-control dito sa ating crossbar. Kaya siya gumagalaw. So nagkakaroon ka ng force, which is tensile dun sa specimen natin. And our specimen is hold to these clamps natin. The force applied is measured using this analog gauge. So nilalaman natin dito kung ilang force na ina-apply natin sa materyales. And it is partnered with dial test indicator here. So nakikita naman ng dial test indicator yung movement. So yung movement that is equivalent uh, to the length or the elongation happen to this specimen natin. So malalaman din natin yung strain. So ito yung simple setup for a laboratory. For industrial type, meron din mga gantong klase na laboratory type. So usually ginagamit dyan is electromagnetically powered. So may motor siya no, sa loob. So yung motor na ginagamit na yon, siya yung kumakain dun sa ngipin ng power screw. So pwede na siyang mag-move traversely within this bar natin. So pwede mo nang applyan siya ng tensile force. And the specimen is hold with these clamps. So usually ginagamit na specimen dito is malalaki of course compared dito. The difference between the two, the major difference between the two is that in this type of setup, manual yung pag-graph ng stress strain diagram. Usually sa mga ganitong setup, connected siya sa PC, sa computer, and then si computer na nag-graph nung stress strain diagram na nabuo dito sa ating test. Next, let's talk about shear testing. So in shear testing, it determines the resistance of material under shear force. So it is accomplished by subjecting the specimen to a controlled shear until failure. Lahat yan failure, no? Kasi destructive test nga. And then measuring and recording the required parameters. Just like the measured parameters from tensile test, i-measure din natin dito is yung force. So shear force naman ang ating mini-measure. Same goes with the area para malaman yung stress. Okay, let's talk about types of shear test. So we have two basic types of shear test. First, we have fastener shear method and lap shear of adhesives. So this differentiate natin siya later. Describe muna natin tong fastener shear method. So in fastener shear method, imagine we have these two set of plates that has a different material to the shear pin na i-study natin mamaya. So itong plate na to, siya yung nakakonect dun sa ating UTM or other machine for shear testing. And then this plate, magbubutasan yan and lalagyan siya ng pin. So bale, ang pag-aaralan natin dito for shear testing is the pin itself because siya yung nakakatanggap ng shear forces. So kaya siya tinawag na single shear because meron siyang one pair ng shear force. So we have two forces that has same magnitude but opposing direction. just like this. So mangyayari, magkakaroon ka ng shear force dito. Next, we have double shear. Tatlong plates naman yan. And then magkakaroon ka ng dalawang shear, no? Next, for the lap shear of adhesive, we will study the shear strength of the adhesive na ginamit natin. Usually adhesives, resins yan. So same pa rin ang procedure, pero sa halip na pin ang ginamit, adhesive yung pinandikit dun sa dalawang metal natin in a lap joint manner. Kaya nga siya tinawag na lap shear. So this is single shear. For the setup naman ng double shear, ganito yan. So next, let's talk about bending or flexural testing. So in bending tests, so it deforms the test material causing a concave surface or a bend to form without the occurrence of fracture. It is still considered a destructive test because yung material natin nagkakaroon tayo ng plastic deformation. Okay? On the other hand, pag sinabi naman nating flexural test, so nagbibigay tayo ng force until the material will have a fracture or masira na yung material natin. So yun yung difference between the two. Pero basically, the operation bit of them is the same lang din. So the purpose of this test is to determine the material's ductility, bend strength, fracture strength, and resistance to fracture. So usual equipment na ginagamit dito is this. So simple setup lang. Meron kang dalawang chuck dito that holds the piece metal. And then we have a dial test indicator connected to the piece metal natin. So if we applied a force here by due to weight, kasi meron kang hanger dito, no? Na patungan ng weight. Pag nilagyan mo ng weight yan, of course, the piece metal natin magbe-bend. So yung movement by that bend will be measured using this dial test indicator. Next, we have loading through hydraulic or electromagnetic actuation. So the movement of the load natin is due to hydraulics na. So meron kang piston or linear actuator that pushes the piece metal natin. And the piece metal or the specimen is supported by these two blocks. So same pa rin ng ibang test, gaya ng ibang test, ang nami-measure dito is the force, no? And then we can observe that for the deformation na nabuo. Next, let's talk about torsion testing. So in torsion testing, it determines the behavior of a material when twisted or under torsional forces as a result of applied moment that causes shear stress about the axis. So si torsion test, nagkakaroon ka ng twisting force, making the piece metal has a shear stress within the grains ng metal or the specimen. So the material or the equipment na usually ginagamit din dito is the same lang din doon sa flexural stress or the bending test. We have this two-collet chuck that holds the piece metal, pero sa halip na yung load natin is nilalagay sa gitna, nilalagay natin siya dito sa dulo. Because itong itong chuck natin is movable. So pag meron yung certain load, it will twist or iikot magro-rotate tong chuck natin. So, di ba in torsion, important yung torque. So, mame-measure natin yung torque using the load multiplying to the radius ng patungan ng loading natin. With the deformation naman, the angle of deformation is measured by the dial test indicator pa rin. Also, we have electromechanical torsion test machine. So, ang nag-iikot naman sa kanya is motor na. And digitally acquired din yung values for torque. So, hindi mo na kailangan i-measure using this. Next, let's talk about hardness testing. So, hardness testing typically performed by pressing a specifically dimensioned and loaded object, or sometimes called indenter, into the surface of the material you are testing. So, nilalagyan natin ng indention. Pangkaraniwan yon kasi mamaya i-discuss natin na maraming type of hardness test. So the hardness is determined by measuring the depth of the indenter penetration or by measuring the size of the impression left by an indenter. Next, let's talk about the different types of hardness testing. So meron tayong three types. So types of hardness measurements are first, indentation hardness. Yung indentation hardness, ito yung dinefine kanina, no? Wherein naglalagay tayo ng indention to a surface of the material. And then measuring the size and the depth of that indention, that will be the parameter that we'll be going to using on calculating the hardness. So the different types of hardness test are first, Brinell test, second, Vickers test, and lastly, Rockwell test. So lahat yan, i-discuss natin later on. The next type of hardness measurement will be the rebound hardness. So in this, sa halip na yung indenter natin is pushed to the material natin. So ang nangyayari naman dito is dinadrop or by impact. So indenter is dropped on metal surface and the hardness as the energy of impact. So the measurement of the hardness is equivalent to the energy ng impact natin. And the types of this type of hardness measurement will be the rebound hammer test and lib rebound test. Lastly, the last type of hardness measurement is the scratch hardness. So it defines as the ability of material to scratch on one another. So dito, kung familiar kayo sa Mohs scale, so ito yon yung scratch hardness. So ini-scratch yung surface ng material para malaman yung hardness niya. In which, ang scale niya, ang pinakamalambot will be the tall, which is equal to 1, and ang pinakamatigas will be the diamond, which is equivalent to 10. First, let's talk about Brinell hardness. So ang unit natin for Brinell hardness will be HB. So, ang nag-propose na itong Brinell hardness method natin in hardness testing is a Swedish engineer named Johann August Brinell in 1900s. So, hence, the name of Brinell sa kanya pinangalan niya, no? So, it characterizes the intention hardness of material through the scale of penetration of an indenter loaded on a material. So, ito yung example of a uh, indenter na ginagamit natin for Brinell hardness. So, meron kang spherical indenter na nilulubog sa piece metal. So, big D, that will be the diameter of the indenter size, and small d for the diameter ng indention. So, for the equation in solving the BHN or the Brinell's hardness number, BHN, that is equal to 2P all over pi big D, quantity big D minus square root of big D squared minus small d squared. So, yung P natin, that will be the force exerted to the piece metal. Next, example of hardness testing using indention is Vickers hardness or HB. So, it is developed in 1921 by Robert L. Smith and George E. Sandland at Vickers Limited. So, ito yung company nila, no? So, hence the name of Vickers hardness. So, ginamit nila to as alternative to the Brinell method. So, characterizes the indentation hardness of material through the scale of penetration of an indenter loaded on a material. So, ang formula natin in solving for the HV or the Vickers hardness number is equivalent to 1.8544 F all over D squared. Ang kadalian nga lang dito sa ating Vickers hardness, hindi mo na kailangan i-measure yung indenter mo. Kasi in comparison doon kanina sa Brinell hardness, uh, kailangan natin sukatin yung diameter ng indenter. Dito, kahit gaano kalaki yung indenter mo or gaano kaliit, as long as it penetrates the material natin or indents the material, okay lang. Kasi ang mini-measure lang naman talaga natin dito para mahanap natin yung Vickers hardness number will be the length of our indentation, which is small letter D. F, that will be the force exerted on the indenter natin. Lastly, the last example of our indentation hardness testing. So it is developed on 1914 by U.M. Rockwell and Stanley P. Rockwell and approved for patent on 1919. So the Rockwell test measuring the depth of penetration of an indenter under a large load or major load compared to the penetration made by a preload o tinatawag nating minor load. So the Rockwell hardness number is calculated using this equation. So our formula for this will be N minus D all over S. N and S are empirical numbers na makikita sa table ng Rockwell. Mamaya ipapakita ko yan. And ang name-measure lang dito will be the D. D is the depth happened when the preload and the major load began. So, the difference between the depth of the preload and major load, yun ang ating depth. So, the value for our N and S, makikita natin sa table ng Rockwell. So, meron silang table here, wherein meron silang different scaling and different abbreviation for the number. May katumbas din yan na load na nilalagay uh, for the force applied to the indenter. And different scale has different types of indenter din. So makikita natin sa rightmost part ng ating table the value for N and S. So yun yung ginagamit natin in calculating the number or the Rockwell hardness number. Next na pag-usapan naman natin is the rebound hardness test. So in rebound hardness test, kagaya na banggit ko kanina, the difference between this and then the first test, which is the indentation test, yung indenter natin will be moved to the specimen by an impact. Kasi doon sa indentation process natin of hardness testing, pinapwersa mo siya doon sa materials natin using compressive force. Ito naman by impact. So the rebound hardness test is designated by HL. So ganito ang itsura niya, no? So it is developed in year 1975 by Liv and Brandestini to provide a portable hardness test for metals. So spherical tungsten carbide tip accelerates on the test surface by a spring force. So ito yung kanyang schematic diagram. Ito yung kanyang surface na itsura, no? Sa loob niya ganito ang itsura. So we have this moving piece metal na merong spring, no? What will happen is that if we remove the spring force, magkakaroon ka ng movement of impact by this coil. Then the edge of our metal will reach to the piece specimen natin. Then itong piece natin or the tip natin is made out of tungsten carbide tip. So yung measurement nito, by digital na yan using this equipment or tool. So hindi mo na kailangan pumunta ng materials testing laboratory para malaman yung hardness niya. So meron ka ng portable tool in order to determine the hardness ng material. So, ito yung kanyang working principle. So, initially, the carbide tip is located at a specific height or distance between the surface, no? And then, if we remove the spring force, magkakaroon ka ng impact. Itong velocity na yan, that is the velocity of rebound. And then, after niya tumama dyan at lumubog at a certain depth, it will move upward with the velocity of impact, and it will return eventually the first to the last position niya, HR. So for measuring or calculating the rebound hardness test, the formula will be the ratio of the velocities. So velocity R, or the velocity of rebound, all over the velocity of impact. So that will be the rebound hardness test. Lastly, the last type of the hardness testing will be the scratch hardness test. So usually ginagamit siya sa mga minerals, hindi sa mga metals and alloys. So it is developed by mineralogist Friedrich Moss in 1820. So scratch hardness tests are used to determine the hardness of material to scratches and abrasion. So meron kang sharp edge, tapos ina-apply niya ng load, wherein binibigyan mo ng scratch or abrasion yung piece metal natin. So, kagaya na banggit ko kanina, si Friedrich Moss din yung nag-develop ng Moss scale, wherein talc yung softest material niya with a value of 1, and then the diamond is the hardest material with a value of 10. So let's talk about naman yung toughness testing, which is the last part ng ating video. So the toughness testing, tinitignan natin yung toughness ng material. So first, pag-usapan natin yung first type, which is the IZOD impact test. So it is described by English engineer Edwin Gilbert. So the IZOD impact holds the sample vertically with a V-notch facing the pendulum. Striking point is the top of the sample. So tingnan natin tong schematic diagram ng IZOD impact test. So we have this rod or lever, and at the end of that lever, meron tayong striking edge. Itong striking edge na yan, mabigat yan. So by gravity, this striking edge will move or swings towards the specimen with an impact. Then the impact will be measured by this scale at gagalaw tong friction pointer natin. As you can see, our test piece is supported with the machine itself. In IZOD impact test, our specimen meron tayong V-notch or meron tayong uka na pa letter V. And then the V-notch is facing towards the striking edge natin. And the striking position or the striking point will be at the top of our specimen. Next, let's talk about the last part or the last example of toughness testing, which is the Sharpie impact test. So it is developed by Georges Sharpie in 1900s. So the Sharpie impact testing holds the sample with a V-notch facing away from the pendulum. So kabaligtaran siya kanina, no, ng IZOD test. Kasi si IZOD test towards the pendulum, ito naman is away. So basically, the construction is the same. We have a lever and a pendulum or the striking edge. By weight, magro-rotate siya or magsiswing towards the specimen. The difference between the two, the Sharpie and the IZOD, is the specimen itself. In Sharpie, yung specimen natin naka-hold at both ends. Kasi si IZOD, one end lang yan. No? And then the positioning of our specimen is that the V-notch in Sharpie is away from the striking edge. Kung kay IZOD naman is towards the striking edge. Next is the point of contact. Si Charpy doon sa gitna, sa middle part. Kay Izod naman doon sa tuktok ng specimen. So that is the difference between the two. And then the measurement of impact in terms of energy or joules is measured here in our analog gauge. So that will be the end of the lecture. If you have any questions, you can message me on my messenger or email me. Thank you.
Fire.
Emmy, faculty, yeah. Emmy, faculty, yeah. Emmy, faculty, yeah. Emmy, faculty. Siya naman si Sir Ivan Espinosa, dulo ng pangalan. Pangako di mahihirapan at hindi kanya iiwan.